Hello and welcome to geometry. This is our lesson for surface area for three-dimensional solids. So today we're going to be looking at surface area formulas for all prisms and cylinders and then all pyramids and cones. Okay, so you've seen surface area formulas and you have already previously learned how to identify parts and plug into the formulas. So what I'm going to show you today is one, where the formulas come from, and then two, a more efficient way to be able to use the formula and the way that I'll want you to show me in calculating all of your surface area problems for this class. Okay, so let's start out with the prism and the cylinders. If you kind of think about it, a cylinder is really just a prism because by definition, a prism is just any three-dimensional solid that has two parallel and congruent bases. Okay, so if you're looking at the pictures I have a pentagon prism, right? Because I see that I have two pentagons that are congruent and they are parallel to each other, right? So here's one and then the other one's back here. Okay, and they are attached together by these lateral surfaces. Okay, so these lines that I'm drawing to connect the two pentagons together, that is going to designate how tall your prism is. So this length, whatever that length is going to be the height of our prism. And then the pentagon, these pentagons, these are the bases. Okay, and you know that from before. With a cylinder, it's really the same idea. It's just this time you have a base that is circular. Okay, so there's your base. And then the line connecting those two bases together, that's your height. Okay. All right, so for our surface area formula, let me switch colors here. Surface area formula, you're measuring all of the area for your prism. So for all of our prisms and our cylinders, we have a total of two bases. So we're going to take 2 times whatever the area of the base is. Plus, we need to find a way to add up all of these lateral faces, right? Or with a cylinder, we got to add up all that stuff that's around the outside, the lateral. All right, well, let's go to another page here. If I unfold my lateral area of my pentagon, I'm going to have these rectangles. And since it's a pentagon, I'm going to have 5 of them, right? So 1, 2, 3, 4, need one more. Right, so 1, 2, 3, 4, 5. Got 5 lateral faces. Okay, but if you think about it, this is really just one giant rectangle. So all we need to know is how long this edge is and how long this edge is. Okay, well, where do they come from? These edges are attached to the pentagon from our original picture, right? So that is really just adding up all the sides of the pentagon. So if we're going to add up all the sides of the pentagon, that's just the same thing as the perimeter. Okay, this other side of our rectangle, so this right here, where does that come from? That is just the length that connects together the sides of the pentagon, which we already identified as the height. So that means this big giant area, which is the lateral area, is just equal to the perimeter of the pentagon times the height, right? Base times height for a rectangle. So perimeter times height. Okay, so back to our formula page then. For surface area, we have 2 bases plus our lateral area. We just said that was just the perimeter times the height. Okay, and that's going to work for both a prism and a cylinder. Just for a cylinder, your perimeter is the same thing as circumference 2 pi r, and the area of the base is just pi r squared for a circle. Okay, so off to the side here, we're going to say that big B is equal to the area of the base, and then P is our perimeter of the base. Okay, so now no matter what type of prism or cylinder, that's going to be your surface area formula that you'll use for all of them. Okay, so let's look at some examples. Right below here it says find the surface area, and you can see that we have 3 prisms. Okay, so let's start with the first one. Your process on this is the first thing you want to do is identify what is the base. Okay, so the base of this prism is just going to be a rectangle. And remember, it's not always sitting on its base. You're going to see that here in a moment. This one, it just so happens to be that it is sitting on its base, but that's the base. So I'm going to shade that in so I remember that's my base. And remember, the way that you identify is looking for the parallel congruent polygons. Okay, the height is always the distance between the bases. So right here, this edge is labeled with 6 meters. That is our height. Okay, so what we need to plug into surface area formula is we need to know what is the area of the base and what is the perimeter of the base. So what you're going to do to organize your work is first you're going to calculate the area of the base, which here is just a rectangle, so that's 10 times 4, which is 40. And then you're going to calculate the perimeter of the base. So that's going to be 2 times 10 plus 2 times 4, which will give us 28. Once you have the area of the base and the perimeter of your base, it's just plug and chug. So surface area, that's going to be 2 times the area of the base, which we said was 40, plus the perimeter of the base was 28, times the height of our prism, which was 4. Okay, and we add those all up, and we get that the surface area is 248 meters squared. Okay, so this is the way that I want you to show your work. Don't try to calculate the area of each individual face. Do the base area, do the perimeter of the base, and then use the formula. Okay, example 2. First thing you need to do is identify what type of prism. I know it's a prism because I see that I have 2 congruent parallel polygons. And those 2 congruent parallel polygons are these right triangles. So those are my bases. So let's shade them so we recognize that those are the bases. And again, just because it's not sitting on it doesn't mean that it's not the base. So base is a triangle. Okay, area formula for a triangle is base times height divided by 2. And remember, base and height must be perpendicular, which you do have because it is a right triangle. Right triangle. So 8 and 5 would be my base and my height. So when I go to calculate the area of my base, I do 8 times 5 divided by 2. So that's going to be 20. Next, we got to do the perimeter of our base. So perimeter of our base, we add up all 3 sides. We've got 5 plus 8 plus question mark. Right? So we don't know what the hypotenuse of our right triangle is. Well, we can find that by using Pythagorean. So we need the square root of 5 squared plus 8 squared. And remember, we're only allowed to have 1 round off per problem. So 5 squared plus 8 squared, that's going to add up to give us 89. And it's the square root, so we're going to add square root of 89. Okay, so our total perimeter, you can only add like numbers together, we'll say. So 5 plus 8, that is 13 plus the square root of 89. Okay, so the only other thing we need for our formula is the height of our prism. And the height is the distance between the bases, so that means our height will be 12. Okay, so now we're ready to plug into our surface area formula. Surface area equals 2 bases plus the perimeter times the height. So here we've got 2 times 40 plus our perimeter, we've got to put this inside of parentheses, times our height, which is 12. Okay, type this all into your calculator. Make sure you put parentheses around the 13 plus the square root of 89. Type that in your calculator and you will get 308.8. And our units will be square feet. Okay, our third example, we have another prism. This time we see that we have pentagons for our bases, right? Our congruent parallel polygons. Pentagon 1, pentagon 2, congruent parallel polygons. The distance between our two polygons is our height. So 6 is our height. And we need to figure out what's the area of our base. Okay, well, let's see. First, I'm going to erase the stuff in here so we can see what's given to us. All right, so it looks like they gave us 5 for our side length, and they gave us 4 for the radius of our pentagon. Okay, so let's draw our reference triangle off to the side here. We have 4 as our radius. Our side length is 5, so that means this short leg of my reference triangle will be 2.5 because it's half of the side length. And we do not know what the apothem is. And by now we all know what this angle is. That's going to be 360 degrees divided by 10, so that's going to be 36 degrees. And we need to solve for the apothem. Okay, so 36 degrees opposite side is given to us. We are trying to solve for the adjacent, or you have the hypotenuse given to you and you're trying to solve for the adjacent. Either one will work, it doesn't matter. I'm going to do tangent ratio. So tangent of 36 degrees is going to equal the opposite side divided by the adjacent side. See, my variable is in the denominator, so I'm going to cross multiply. That gives me the apothem times the tangent of 36. That equals 2.5. So that means the apothem will equal 2.5 times the tangent of 36. Okay, so now we can calculate the area of the base. The area of my base of my prism, which is a pentagon, we need to do side apothem number of sides divided by 2. So when we plug that in, my side length was 5. My apothem was 2.5 tangent of 36. I have 5 sides, and I'm dividing by 2. Okay, now on these problems at this point, I will let you round this off. So we're going to kind of break our 1 round per problem rule. I'm going to go ahead and approximate this. You should get approximately 42.5. And then our perimeter of our base, each side was 5, and we have 5 sides, so the perimeter is going to be 25. And now plugging all into the surface area formula, we need 2 bases plus the perimeter times the height. So when we do that, we've got 2 times our base, which we approximated at 42.5, plus the perimeter is 25, times our height, which, let's go back up and look, our height was 6. Okay, type that all into your calculator and you should get that the surface area is about 235. And our units are centimeters squared. So next, we are going to look at pyramids and cones. All right, well first we need to talk about what the formula is and where it comes from. So let's go back to our formula sheet. For a pyramid or a cone, remember you only have one base, right? One base for our pyramids and cones. So one base. Cone has a circular base. Our pyramid, different types of polygons. So for surface area, we've got the area of one base plus, for this one, you need to do 1/2 times the perimeter times the slant height. Okay, and where that comes from is our lateral faces are all triangles. So when you're looking at these individual triangles, this is a lateral face. This is a triangle, so remember area formula for a triangle is 1/2 base times height. So the 1/2 is coming from the area formula for a triangle. The length of the base is coming from the perimeter, right? All these bottoms, all of these, again, similar to what we did with our prism, these are going to all be added up. So that's going to be your bases of all of your lateral faces. And then the height of this individual triangle actually lies along the surface. Okay, so what that is called is the slant height. This is the slant height. It lies on the surface of your pyramid and also on your cone. So on your cone, here's your slant height. And they use a little L for the notation for slant height. Okay, so that's what this little L is in our formula. So you've got the area of one base plus 1/2 the perimeter times the slant height. So I'm going to rewrite that. Surface area equals one base plus 1/2 perimeter times the slant height. Okay, so let's do some examples. In our first picture, we have a, looks like it's not labeled for us, but we're going to call this a square. It's not labeled for us, so, but it only gives us the one side length. So go ahead and label those sides as congruent. This will be a square pyramid. If it weren't a square, it would be a rectangle, which means they'd need to give us another side length. Okay, so first thing we need to do is figure out what the area of our base is. Area of our base, we just need sides squared, so 7 squared, that gives us 49. We still need to know the perimeter of our base, so 7 for each side times 4 sides, that's 28. And the other thing that we need in our formula is the slant height. So slant height is the height along the surface of our pyramid. So right here, that's our slant height, 10. Sometimes you'll have to compute the slant height. This one was given to us. And now we can go ahead and plug into the formula. So one base plus 1/2 perimeter times slant height. So plugging in, area of our base is 49 plus 1/2 times the perimeter is 28 times our slant height, which was 10. And we type that in, and we get that the surface area is 189, and our units are meters squared. So our second example, we have another pyramid. We know it's a pyramid because there's only one base. And again, I don't have the labels on here. They are missing. This is supposed to be a regular pyramid, which means our base is going to be regular, which means this is going to be an equilateral triangle. Okay, so all these sides are 13. Okay, so the area of our base, remember we have the special formula for equilateral triangles where we need side squared times radical 3 over 4. Okay, so when we simplify that, we get 169 radical 3 over 4. That's the area of our base. Perimeter, we have 13 for each side times 3 sides. So that's 39. And our slant height, again, that was labeled for us in the picture. Slant height along the surface, that is 11. So now we plug into the formula. We need 1 base plus 1/2 perimeter times slant height. Our 1 base has an area of 169 radical 3 over 4 plus 1/2 times our perimeter times the slant height, 11. Okay, we put this into our calculator and go ahead and get a decimal. We're going to get 287.7, and our units are centimeters squared. Okay, so those are our 2 pyramids. Not hard, just a lot of computation. But if you organize your work, not difficult. Okay, the next one we have a cone. Okay, so for the base of our cone, base area is just going to be the circle formula for area. So we need pi r squared. Our radius is 8, so that means our area of our base is going to be 64 pi. The perimeter of our base is the same thing as circumference. So 2 pi r, that's going to give us 16 pi. And then our slant height, remember that's along the surface. Slant height is 15. Plug into your surface area formula. We need 1 base plus 1/2 perimeter times slant height. And when you plug that in, we get 64 pi plus 1/2 times 16 pi times 15. And we want to be able to simplify this in terms of pi, just like we've been doing all along. So 64 pi plus 1/2 16 pi times 15 would give you a total of 184 pi. And that would be our exact answer. So remember, always do exact. If it asks you for the decimal, then you can do the decimal, but always practice exact. Okay, and on our final example for the day, we have another cone, but this one is special, and this special case will also apply to any pyramid. Okay, so if you look at what they have given you, they've given you the radius of our circular base, but they did not give us the slant height. Right? Slant height is along the surface, and we do not know what that is. What they did give us is the regular height. Okay, so regular height is 25. We need to know what is the slant height. Okay, well, regular height goes from your vertex of your cone and it drops down perpendicular to your base. So guess what? Right triangle. We can use Pythagorean to solve for our slant height. Okay, so that's what we want to do first. Go ahead and get slant height. Slant height is going to be equal to the square root of 10 squared plus 25 squared. And we just want 1 round per problem, so that's going to be the square root of 725. No need to try to simplify those radicals because you're just going to plug it into another formula and you're going to be getting a decimal, so no need to simplify it. You're going to be rounding it off here in a second anyway. Okay, so square root of 725, leave that as it is. Okay, next we need to know the area of the base. Area of the base, we've got radius is 10, so pi r squared for our area, that gives us 100 pi. And then the perimeter of our base, 2 pi r, that gives us 20 pi. So now plugging in for surface area, we need 1 base plus half the perimeter times the slant height Area of the base was 100 pi plus 1/2 times the perimeter of our base is 20 pi. And then the slant height we found was the square root of 725. Okay, so here I would not make you try to simplify a radical and in terms of pi. So on this one, you'll just put this in your calculator and you'll get an approximate surface area of 1,160.1, and our units are centimeters squared. All right, so those are our basic examples for today. You've got surface area for cones, both given the slant height and the regular height. And remember that last example where we computed the slant height, that can also apply to regular pyramids. So in our two pyramid examples, they gave us the slant height, but you could very easily be given the regular height, in which you would have to compute the slant height using Pythagorean. Okay, so keep that in mind. And then we have all of our prisms where you've got two bases and then you got to add up the perimeter times the height. Again, identify your shape of your base first. That is key on these. And remember, it's not always sitting on its base. You got to identify the two parallel and congruent polygons. Okay, and then once you find your areas and your perimeters, you plug into the surface area formula, and then you're done. Okay, so again, not difficult, just a lot of computation, and you've got to keep your work organized so that one, I can figure out what you're doing if you're doing something wrong, and two, just for the sake of yourself, keeping yourself organized. Okay, so that is it for today. When you guys come back, we will be looking at the problem solving and then also the algebra problems where you've got to solve for missing measurements when they give you the surface area. Okay, we'll see you next time.